As you can see, we have got two things here, which is actually the steel hammer and the oil bath. Okay, so these are the two things that we are going to be focusing with here. So I'm just going to talk about the steel hammer, and we've got the oil bath. All right, so these are the two things that we got here. So let's try and list information. So for them, steel hammer, we are given the mass, which is actually, this is in grams, 3000 grams, and we know that the mass should be in kgs. So 3000 grams, remember, to kgs, you divide by 1000. So you're going to divide by 1000, which is going to give us 3 kgs. Okay, divide by 1000. And we are given the temperature of the hammer, that is the initial temperature of the hammer, which is 180 degrees Celsius. So this is the initial temperature of the steel hammer. So this is the temperature of steel. So this is mass of steel, temperature of steel, again 180 degrees Celsius. All right, what else do we have? It is placed in air. That's the amount, guys. This is milligrams. So this one you divide by 1 million. That is 10 to the power minus 6. So you divide by 1 million. Gram like this, you divide by 1000. Okay, milli, remember, when there is a milli, you divide by 1000. So there is another milli again to convert to grams. This milli to normal grams, you divide by 1000. Okay, then to convert to kgs, you divide by another 1000. So you just simply divide by 1 million. Okay, so you're going to have the mass of the oil bath there. Let's just have M oil, which is, if you divide by 1 million, you're going to obtain 7,0065. Now it's in kgs. Well, the mass should be in kgs. All right. And the temperature of the oil bath is 50 degrees, which is the initial temperature of the oil bath. So just going to temperature of oil bath, which is 50 degrees Celsius. All right. Then the question is to calculate the final temperature of the steel and oil bath, which means the steel and the oil bath combined together, which means we want to calculate T2. We do not know the value of T2. Remember that. So we need the specific heat capacity. Remember that the specific heat capacity of steel and the specific heat capacity of oil. So what is the specific heat capacity of steel? This is what you're going to obtain. Specific heat capacity of steel here, it's 500 joules per kg degrees Celsius. Okay, so it's 500 joules per kg degrees Celsius. All right, then for oil, is there here, the specific heat capacity of oil is 2000 joules. Okay, so this one is 2000 joules per kg degrees Celsius. Why do we need this? Because remember, guys, whenever you combine, we talked about this when you're talking about it, whenever you combine to a material or a steel block or whatever that you're going to have and water or oil like this, there's going to be heat that is lost and heat that is gained. So there's something that is losing heat and something that is gaining. So if we are to cross check, here it is the steel that is going to reduce its temperature. It's going to lose. So here we've got the heat that is lost, and here it's going to gain. Water is the one that is going to gain. So here we are going to have Q gained. So we've got heat lost and heat gained there. So water, the oil bath is gaining. At that moment, the steel is losing, or it lost its temperature, which is the same time as the heat energy. So this is the relationship that you're going to use to calculate that value of T2, the one that you're asked to calculate. So which relationship am I going to use here? Remember, Q lost is equal to Q gained. That is, heat lost is equal to heat gained. And this is for steel, and this is for the oil bath. All right, and we know that heat, it's mass times the specific heat capacity. Then we've got the temperature of steel minus the final temperature, which is equal to mass of oil times the specific heat capacity times T2 minus the temperature of oil. So here we are talking about oil, and here we're talking about steel. This is steel, this is oil, this is oil. All right, so we need the mass of steel, which is 3. We just substitute here. The mass of steel is 3, so you've got 3 times the specific heat capacity of steel, which is 500 joules per kg. So you're going to substitute 500 into temperature of steel, which is 180 degrees Celsius, minus T2. We do not know this value. This is the one that you want to calculate. Remember, the temperature of steel is there. We do the same here. Mass of steel, the space of oil, the specific heat capacity of oil on this part. So the mass of oil, remember, it was 7,0065 times the specific heat capacity of oil, which is 2000. So you've got 2000 there, times T2 minus that is the temperature of oil there. So it's T2 minus the temperature of oil, which is 50 degrees Celsius, this one. So you're going to subtract 50 there. All right, so that's the equation, guys. Let's solve the equation and see what you're going to have. So I'm just gonna combine these two. I'm going to obtain 1500 here into 180 minus T2, which is equal to, I combine also these ones, I'm going to obtain something like 14013 into T2 minus 500. So multiply these two numbers here. All right, then definitely have to expand brackets. So it's 1500 times 180, which is going to give us 270,000. So we multiply these two, then 1500 times minus T, which is minus 1500 T2, which is equal to this times this, which is going to be 14013 T2 minus this one times this one, which is 50. So you're now multiplying to 50 there. So you're going to obtain 700,650, if I'm not mistaken there. That's what you're going to do. Then guys, let's just transpose, okay, collect like terms and see what you're going to have. So you're going to collect numbers. I'm going to left with 200,000. This one to this side is going to be a plus 700,650 there, which is equal to, transpose this, it's going to be a minus. It's a plus because it was a minus, so it's going to be a plus. So it will be 14013 T2 plus this one now plus 1500 T2. All right, so you collected like terms, the one with T to one side, the constants to one side. So you combine these two numbers, add them together, you're going to obtain something like 970650, which is equal to, you add these two numbers, you're going to obtain something like 15513 T2. All right, then definitely divide both sides by 1000, by 15,000, this one, divide both sides. So therefore your T2 is going to be something like 62.57 degrees Celsius. So this is the final temperature of the system, which is the one that is affecting, it's actually affecting the oil and the steel at the same time. So as we saw that it's all about heat lost, so the steel lost while is the oil gained. So from that part you can actually formulate an equation that you're going to use to calculate the final temperature. So that's it, guys, for this question. Let's see another question that we had there. It was on 5.2 now, where we are given a volume of 0.240 cubic meters of oil is heated from 2 by burning coal. Okay, so we are burning coal there. So we've got a volume. Remember, guys, volume in cubic meters. What can you obtain from this volume? Let's just write it down. Maybe you can have something from there. This is our volume. From this is temperature from this one to this one. So this is initial, final. All right, so we've got the initial temperature of 300 degrees Celsius and T2 540 degrees Celsius, which is, so this is the volume of water actually, and this is used, this one is heated from 2 by burning col, so which means we are working with col in everything that we are doing. Is col that we are talking about, but this is for water. It changed from this to this. All right, so the first question is, okay, calculate or determine the change in temperature. So the change in temperature. All right, so the change in temperature, how do you calculate the change in temperature, guys? That's simply subtract T2 minus T1. Okay, so that's the change in temperature. That's T2 minus T1. So this one is just a matter of substituting into this formula. So let's substitute, guys, and see what you're going to have. Our T2 is 540 degrees Celsius minus T1, which is 300 degrees Celsius. So these units are the same, so you're going to obtain 240, which is in degrees Celsius. So that is our change in temperature, 240 degrees Celsius. All right. On 5.22, the quantity of heat required, the quantity of heat that is required. Okay, so take note here. We've got water and we've got the specific heat capacity of water. I think we determine this one, the specific heat capacity of water. We obtained for, did we talk about this today? We didn't. It was oil. Okay, but this one is 4187. Let me show you here. Specific heat capacity of water. You need it. You need this one. So this one is joules per kg degrees Celsius. So you need this one. All right. So because you know that when you are calculating the heat, which is actually the heat required, this is the formula. Q is equal to mass, which is times the specific heat capacity times the change in temperature. So this is the mass of water, the specific heat capacity of water. All right, so what is the mass of water, guys? Here we are given the volume of water in cubic meters. So how do I convert this volume to a mass? That's the question now, because we are given a volume of 0.240 in cubic meters, guys, but we need this mass in kgs, but that is mass. All right. The only relationship that we know so far that we have is to convert cubic meters. That one is easy, to convert cubic meters to liters. All right, that's the only thing that we know we can do. All right, so we know that in a cubic meter we have got 1000 liters. Why am I talking about liters while I want kgs? Okay, you understand me? So if 1 cubic meter is 1000 liters and this is 0.24 cubic meters, so I'm going to just multiply by 1000 to convert to liters. So it's 0.240 times 1000. So if I multiply by 1000, which is going to give me something like 240 liters. Is that so? Yeah, that's 240 liters there. So why are we using 240 liters? Because we have a relationship that is a strong relationship between liters and kgs. For each liter that we have, it's equivalent to 1 kg. So this one is a 1:1 ratio. So if this is 1, this is also 1. So if we have got 240 liters, definitely we have got how many kgs? We have got 240 kgs. That's the relation. So it was easier for you to convert cubic meters to liters than liters to kgs. All right, so we have got the mass now, so you're just going to substitute into the formula. So the mass of water is 240. So that's 240 kgs times the specific heat capacity. All right, that's the specific heat capacity of water. We wrote it here. That's 4187 times the change in temperature. We calculated this, the change in temperature, which is T2 minus T1. We obtained 240. So instead, we are just going to write that change in temperature, which is 240, because we calculated this before. So from your calculator, guys, as you can see, this is now you and your calculator. So you just simplify this. You're going to obtain this big value, 2,411,71200, like this. All right, which is in joules. Okay, so you can just put this to megajoules. That's 6 here, so it's going to be 241,1712. These zeros are not important, so it's now megajoules. Or you just divide by what? By 6, by 10 to the power of 6, or 1000. Now it will be mega, because mega is 10 to the power 6, so you divide so that you can write it as mega. So that's it, guys. We've got the value or the quantity of heat, that is the quantity of heat. Take note, it's quantity of heat. So that is the heat required, the amount of heat that is required. So this is the heat that is there, and this heat is the one that is also used by the same coil. Take note, guys, it's used by the same coil that we are given. So it can help us now to calculate 5.23, where we are given to calculate the quantity of coal required though. So this is not like the heat of coal, but the quantity, because already this coal is using the same heat, which is this one. So the quantity of coal, remember that, guys, this heat that we are talking about is also the heat that is affecting what? That is affecting coal. So if it is coal, I can write this relationship here. Remember, the energy is equivalent to mass times the heat value, because I want the amount, I want this, that is the quantity of coal, how much, like how many kgs of coal were used, that is the quantity of coal. So I need the mass, and the only relationship is mass times heat value, because the energy E, I've got this E is the same Q here, so this Q can be written as E. Okay, that's the energy there, so you can write E or Q, just choose which one is best for you there. So since it is mass times heat value, I need to find, or I need to have the heat value of coal, and the heat value of coal is there. The heat value of coal is 30 megajoules per kg. Okay, so you've got 30 megajoules for this one, and the energy is the one that we just calculated now. So we're going to use this energy that we determined. What was our energy? This was 241.1712, this one. So you can round off to 2 decimal places if you want, but take note, these are megajoules, so it's going to be 5, because also our heat value is in megajoules. So it's the mass times the heat value in megajoules also. So I can find the mass there. How can I find mass? I can simply divide, because I'm multiplying here, so divide by 30 there, divide by 30 there. This can cancel. So therefore, the mass of coal which was required is 8.03904 kgs. You can round off to 2 decimal places, to 3 decimal places like this, which is kgs. All right. So that is the quantity there, which is actually in kgs, like the mass. You're actually calculating the quantity of coal. So this is the mass of what? Mass of coal. So as you can see, guys, there's a great relationship that you need to know in formulating and in connecting formulas. Okay, you need to connect the formulas in a proper manner. Okay, anyways, let's see the other part that we're given, that is on 5.3, state 3 advantages of steam. Okay, we've been talking about this. Okay, anyways, these are the ones that I'm having for you guys that you can actually take from, and maybe you can you have something there that you can memorize and also find others. So still, the advantages of steel that we have: steam, not steel but steam. All right, so we've got steam can be used repeatedly. Okay, that one, from steam it evaporates, now back to water, you use it again. Okay, then coal, which is the fuel, and water are reasonably cheap and readily available. So that's another advantage. And the steam plant has a long life. Once the plant is there, it actually takes a lot of time to have any other faults that can happen. So it has a long life. That's it, guys. And we have got 2 disadvantages of steam. Okay, what are the disadvantages now that we can have which can affect us? Maybe we've got a steam plant that we are using, so these can be the disadvantages. I don't know if everything is clear, but there we've got water is lost due to evaporation. yeah, it can be a disadvantage, but still this water you're going to get it back. Anyways, it lost for that moment. Maybe it takes time, you just due to our rainy seasons and so forth, maybe it takes time, but that's a disadvantage. The initial cost of the installation is very expensive. Okay, so to start that plant, guys, it's gonna take a lot of money. It's very, very expensive. Yes, it takes a lot, it's a long life period that you have, but to start it, it's very, very expensive. And as a result of the combustion, the atmosphere is contaminated. Yes, because you're talking about coal there, you are burning coal. So actually the atmosphere is going to be contaminated due to this combustion of the fuels that you shall be having, because you shall be having coal, and not only coal, but some of the fuels which will be used there, and it's going to affect the atmosphere. A steam layout must be erected where water and coal is available. All right, so it takes time. You have to locate a place where you can find water at the same time coal is there. So as you can see, guys, it's very, very difficult to find such a place, and that's why we've got fewer places or fewer regions where we have got these plants, because you need to have all the requirements at the same place. So that's it, guys, on the disadvantages of steam. So if you are to take note, that was everything for you to obtain 50 bucks, which means it takes you to know most of the stuff on heat or for you to know, to actually have this. And there are different types of questions. As you've been watching our classes, you saw that there are so many questions, different types of questions actually that you shall be having. So that's it, guys. We shall be having more questions to come from Amazon African Motive. So if you are not yet part of the family, please become part of the family by subscribing, and don't forget, guys, to share our classes to our friends and colleagues, because they need also to benefit from this information. So please make sure that you save a soul today, you save someone today by sharing this information that you are having from Amazon African Motives. Till we meet again.